This is one of the very important, most important topics, both for competitive exams as well as your intermediate or CBSE board exams. Okay, and whatever the topics we discussed till now will be much helpful to understand Kohlrausch law. Okay, right. What is Kohlrausch law and all we'll discuss now. And just few minutes back we discussed limiting molar conductivity. Limiting molar conductivity means molar conductivity at infinite dilution. Means when we add more and more and water, then concentration becomes almost zero. At that point of time, the molar conductivity is called limiting molar conductivity. Right. How to measure limiting molar conductivity? Limiting molar conductivity is measured by Kohlrausch law of independent migration of ions. So we'll try to understand the meaning of this sentence. Kohlrausch law. Kohlrausch law of, for what Kohlrausch law? And what Kohlrausch law is explaining about? Independent migration of ions. Independence means individual. Migration means movement. Ions. The independent movement of ions. What ions? Cations, anions. This for example, if you take sodium chloride, so in sodium chloride Na plus and Cl minus ions will move freely. When you put NaCl in water, what happens? NaCl ions will move very freely. So now come to the statement. This is the definition or statement of Kohlrausch law. So very important statement. All of you note down. Limiting molar conductivity of electrolyte can be represented as the sum of the individual contribution of the anion and cation of the electrolyte at limiting molar concentration. This is one form of statement. And if you can find different statements in different books, but the meaning of all those statements is same. So I will explain what is the meaning of this statement. Limiting molar conductivity of electrolyte can be represented as sum of the individual contribution of anion and cation. Okay, at a limiting molar concentration. I will go to my tab so that 1 second. I'll take my tab. I'll try to explain this. Suppose limiting molar conductivity of lambda naught. Why we put lambda naught 0? This 0 represents 0 concentration. Otherwise, you can also write like this: limiting molar conductivity lambda infinity. Okay, and you may get one doubt, sir, lambda means like this, no, lambda symbol is this, no, why you are writing lambda like this? So this is also lambda, and this is a capital lambda, and this is small lambda. That's the small difference. Lambda, both are lambda only. So limiting molar conductivity of NaCl, sodium chloride, is equal to limiting molar conductivity of individual ions. What are the individual ions that sodium chloride contains? Na plus and limiting molar conductivity of Cl minus. That means cation, Na plus cation, and Cl minus anion. Getting the point? That means limiting molar conductivity of an electrolyte is equal to limiting molar conductivity of cations and anions of that electrolyte. That means sum means total. Total limiting molar conductivities of cations and anions. That's all. Very simple. Very easy. That is Kohlrausch law. Kohlrausch law is saying that if you want to find limiting molar conductivity of any electrolyte, suppose if I take acetic acid, limiting molar conductivity of acetic acid CH3COOH is equal to limiting molar conductivity of CH3COO minus plus limiting molar conductivity of H plus. Okay. My suggestion is you also take a notes of this. Okay, again we'll get this. 1 second. This is the statement of Kohlrausch law. That is for NaCl electrolyte. Just I have written now the same thing. You also please note down lambda m naught of NaCl is equal to, here capital lambda, next one is small lambda. That's the small difference. And this is one example. Next, if an electrolyte on dissociation gives V plus cations and V plus anions, that means if cations and some n number of cations and V number of cations and V number of anions, then the same formula is changes to like this. Okay, I will make you understand. Don't worry. So lambda m naught is equal to V plus of limiting molar conductivity of cations plus V minus for anion, limiting molar conductivity of anion. So I will make you understand. Here lambda naught plus and lambda naught minus are the limiting molar conductivity of cations and anions respectively. Okay, I will try to take a small example to make you understand. Suppose if I take a limiting molar conductivity of MgCl2, magnesium chloride, that is equal to limiting molar conductivity of magnesium Mg plus 2 plus limiting molar conductivity of Cl minus. But here small problem is MgCl2 dissociate into Mg plus 2 and how many chloride ions are there here? Chlorines are 2, no? 2 Cl minus. 2 chloride ions will get. Getting the point? So we have to multiply total 2 chloride ions we are getting, no? 2 into limiting molar conductivity of Cl minus. I hope you understood this. Shall I take one more example so that you can understand little more easily? I'll take aluminum chloride, AlCl3. How aluminum chloride dissociates? Al plus 3 plus 3Cl minus. If I ask you to write Kohlrausch law, apply Kohlrausch law for this electrolyte AlCl3, then you have to write limiting molar conductivity of aluminum chloride AlCl3 is equal to come on, limiting molar conductivity of aluminum ions plus limiting molar conductivity of Cl minus ions. But how many moles of Cl minus ions are there? 3 moles. So we have to mention that 3 here. Getting the point? Likewise, we have to write. Okay. One more example I'll take. You try yourself. Na2SO4. You try yourself fastly. Na2SO4 gives 2Na plus SO4 minus 2 ions. So limiting molar conductivity of Na2SO4 sodium sulfate is equal to, come on, limiting molar conductivity of Na plus ions. Na plus ions. How many moles of Na plus ions are there? 2 moles. So multiply with 2 plus limiting molar conductivity of SO4 minus 2. How many moles of sulfate ions are there? Only 1, no? So 1. That's all. So likewise, you can write the limiting molar conductivity of any compound. That's the meaning of that. So here one small problem is given. Let's try to find the answer for this. I will go little fast, and I'll try to make you understand this. See here, small problem is very important. Calculate limiting molar conductivity of calcium chloride. We have to find calcium chloride limiting molar conductivity from the data given. So molar conductivity at infinite dilution of calcium ion is 119 Siemens centimeter square per mole. Limiting molar conductivity of chloride ion Cl minus ion is 76.3 Siemens centimeter square per mole. These are the two values given. Can you find the limiting molar conductivity of calcium chloride? Both these two values are given now. How to find? First you do one thing. Write the dissociation of this compound CaCl2. CaCl2 is dissociated into Ca plus 2 and 2Cl minus. How to write the formula for this? limiting molar conductivity of calcium chloride is equal to limiting molar conductivity of calcium Ca plus 2. How many calcium ions are there, dear students? Only one. So only one we have to take. But chloride ions are 2, no? Plus 2 into limiting molar conductivity of Cl minus ions. Okay, here limiting molar conductivity of calcium ion is given, chloride ion is given. You substitute both the values. What is the value of calcium? It is 119 and chloride is 76.3. Okay, 119 plus chloride is 76.3. But how many chlorides are there? Two are there, no? 2 into 76.3. So if you do these two, you multiply these two and you will get some answer, some value, and add 119, then you will get the answer. So your answer will be nearer to 270 and 80 in between. So let's go to the options. And the options are 217, so 271. Okay, 27 wrong, 27, 21 wrong.
Yes, sir.
So
Understood.
second option, na? Second option.
That's
So this is the formula we have to apply, and this is our answer. Isn't it? Very simple. If you understand the concept, you can answer the questions very easily. So many students feel difficulty in understanding this. Sir, how to this how to do this formula, this problem and all. So now I hope you understood very well. Right? Next we'll move on to the next topic. Weak electrolytes will take. What is weak electrolyte? I already told you. Weak electrolytes do not undergo complete dissociation. If you take 10 grams acetic acid, only 1 gram will undergo dissociation. Means 1 gram will be becoming into CH3CO minus and H+. Remaining 9 grams will be like that only. Just to make you understand, I am taking 10 grams and 1 gram, 9 gram like that. Okay, it will be much lesser than that. In such electrolytes, the change in molar conductivity dilution is due to increase in the degree of dissociation. Okay, is already told you. I already told you when degree of when we increase the volume, when we keep on adding water again and again and again, at certain point, its concentration becomes almost zero. When you add more and more water, okay, one small question, dear students, what are weak electrolytes? Weak electrolytes do not undergo complete dissociation. Their dissociation is less generally. But practically what happened, when you add more water and again, and again, the degree of dissociation of weak electrolyte increases. That means it keep on dissociates. I'll take one small example here again. I am going to take 10 grams of acetic acid. 10 grams of acetic acid. Out of 10 grams, only 1 gram of acetic acid undergone dissociation. I have taken 10 grams, but only 1 gram undergone dissociation. When the volume of the solution is 100 ml, 100 ml. Suppose if I take, if I add one more 100 ml of water, then 2 grams of acetic acid dissociated. If I add one more 100 ml of one more 100 ml of water, then 3 grams of acetic acid dissociated. If I am keep on adding water, suppose some 2000 ml, then it undergoes complete dissociation. 10 grams. Then whatever the 10 grams of acetic acid you have taken, the complete acetic acid dissociated into ions. That means what we have to understand, generally weak electrolytes, one second, generally weak electrolytes have very less degree of dissociation. The degree of dissociation is very, very less. But when you add more and more water upon dilution, on dilution, their degree of dissociation increases. Degree of dissociation increases. Degree of dissociation is represented by the symbol alpha. Okay. Okay, we'll come to the slide. So this is the meaning of this statement. Here one graph is given according to Debye-Huckel-Ansager equation. So if you draw a graph curve for weak electrolytes, we'll get a curve like this. Dear students, for strong electrolytes, already we have seen the graph and we get a straight line with negative slope. For weak electrolytes like acetic acid, we will get curve like this with negative slope only, but we'll get a curve. Okay, remember this. Next, for weak electrolytes, lambda m increases steeply on dilution as shown in the graph, right? According to Kohlrausch law, one small question. According to Kohlrausch law, the limiting value of molar conductivity of an electrolyte A2B3. See, my dear students, this is very challenging for you. And if you can answer this, really amazing, because I already given small hint just few minutes back. This is the electrolyte salt A2B3. So what is this 2? 2 is the valency of B. 3 is the valency of A. If you have to write, this is the which type of electrolyte? Okay, A2B3 now, A2B3. Okay, I will give you. See, if this salt A2B3 undergo dissociation, will get A plus and B minus. Okay, cation and anion, for example. Here A2B3, 2 moles of A, 3 moles of B. Okay, good. What is the valency of A? Valency of A is nothing but here whatever the number is there in the subscript of B. This 3 is the valency of A. 2 is the valency of B. That means A plus 3, B minus 2. Be careful. Once again, I am going to write A to B3. The salt will be dissociate like this. 2A plus 3B minus. That's okay. Now, what is the valency? Valency of A is 3. Valency of B is 2. So, plus 3 minus 2. Okay. If you are new to this, no problem. You no need to worry. So if you can understand this, now you can answer this question very easily. So if you don't understand that, you cannot answer this. These are the questions asked in previous competitive exams. Come on. Which may be the correct option according to this just now I explained, and dissociation. Which one is correct one? 2 moles of A, 3 moles of B.
D.
D. Good. D is the correct option. Excellent. Applications of Kohlrausch law. This is what just simply Kohlrausch law. Now we are going to discuss applications of Kohlrausch law. Okay, note down these points also. Otherwise, at least take the screenshot. What is the first application? Molar conductivity of for weak electrolytes is obtained by using Kohlrausch law of independent migration. First and most important application. Application means use. The use of Kohlrausch law. First and important use is Kohlrausch law is used to find molar conductivity of weak electrolytes. Okay, Debye-Huckel-Ansager equation for strong electrolytes. Kohlrausch law is for weak electrolytes. Getting the point? Right. And for this, a few examples. See here, acetic acid is weak electrolyte. Acetic acid is weak electrolyte. So it needs some explanation. I will explain you. Molar conductivity at infinite dilution of weak electrolyte, acetic acid, is equal to, you may get small doubt here. Sir, what sir here different compounds are taken? We have to find acetic acid molar conductivity, no? But why to take sodium acetate, hydrochloric acid, sodium chloride? I will explain. Since a weak electrolyte do not undergo complete ionization, it is a bit difficult to find its complete actual molar conductance, molar conductivity. So we need to depend on molar conductivity of strong electrolytes at infinite dilution. See, this is a salt. Sodium acetate is a salt. Salts are strong electrolytes. Sodium chloride is a salt, strong electrolyte. Hydrochloric acid is a HCl is a strong acid, strong electrolytes. Strong electrolyte, strong electrolyte, strong electrolyte. By using the values of strong electrolytes, we can find the value of weak electrolyte. That is the meaning of this. So we have to find the molar conductivity of acetic acid, which is a weak electrolyte, by using the molar conductivities of strong electrolytes. Okay. Now I will explain on my tab. Okay. Which weak electrolyte we have taken? Acetic acid, no? CH3COOH. It undergoes dissociation like CH3COO minus and H plus. You also please note down. Compulsorily you have to note down. Okay. CH3COH gives CH3CO minus and H plus. Next, this is a weak electrolyte or weak acid. Now I am going to take hydrochloric acid, HCl, gives H plus and Cl minus, complete ionization. NaCl gives Na plus and Cl minus. Next, sodium acetate, CH3COONA. It is called as sodium acetate. If you don't know the name, please note down. It gives CH3COO minus and Na plus, or Na plus CH3COO minus. These three are strong electrolytes. Okay, na? Actually, we need to find the molar conductivity of this one, weak electrolyte, by using these three. What are the ions present in a weak electrolyte? What are the ions? Acetate ion and H plus ion. That means we need acetate ion and H plus ion. Listen carefully, my dear students. Listen carefully. This is a very important topic. That's why I'm going little slow. Among the given three strong electrolytes, where can you find these two ions? ఇచ్చిన వాటిల్లో మీకు ఈ రెండు అయాన్స్ ఎక్కడెక్కడ ఉన్నాయి? Where can you find acetate ion and H plus ion? You can find H plus ion here and acetate ion here, isn't it? That means you want acetate ion and H plus ion. Where you are finding that? H plus ion you are finding in acetic acid, HCl, and acetate you are finding in sodium acetate. So you have to add these two. You have to add these two. And you have to subtract this one, middle one. Why we need to subtract? We need H plus. We need H plus. But we don't need HCl minus. We don't need. Here we need CH3CO minus acetate. But we don't need Na plus. That means overall we don't want Na plus and Cl minus we don't want. That means we have to subtract this. Okay. Now limiting molar conductivity. Note down, please note down. Limiting molar conductivity of CH3COOH is equal to limiting molar conductivity of what we need to add? This one, last one and first one. CH3COONA plus limiting molar conductivity of HCl minus limiting molar conductivity of NaCl. Okay. Okay, I told you many times, note down. I hope you are writing all these things. Now I am going to expand this. Limiting molar conductivity of CH3COOH is equal to, I am going to expand this part. Limiting molar conductivity of CH3COO minus plus limiting molar conductivity of Na plus. See, this is the expansion of this part. Okay. Similarly you do for HCl. Limiting molar conductivity of H plus limiting molar conductivity of Cl minus. Okay, and this is the expansion of HCl. And how do you expand NaCl? Here minus is there, minus limiting molar conductivity of Na plus, okay, plus limiting molar conductivity of Cl minus. Okay, here we have used minus symbol. Okay, sorry, there's 10 minutes left. Okay, after 10 minutes, okay, I will tell you whether you need to join or not. Most probably no need. If there is necessity, I will tell. Now, dear students, now cancel all these things. Similar things you cancel. See, Na plus, limiting molar plus Na plus. Here minus Na plus, cancel. Plus Cl minus, minus Cl minus get cancelled. So finally what you get? Limiting molar conductivity of CH3COOH is equal to limiting molar conductivity of, what is left here? This one is left now. CH3COO minus plus limiting molar conductivity of H plus. That's all. So that means to get the limiting molar conductivity of weak electrolyte, we have added two strong electrolytes and we have subtracted one electrolyte. If you have not understood this explanation, you no need to worry. And again I will explain this many times in our coming explanations. But it is very, very important. Note down this. And what you need to do is you have to continuously note down whatever I am explaining on the board. See, the same thing whatever I have explained now, the same thing is displaying on the screen. Limiting molar conductivity of CH3CO minus and Na plus, H plus and Cl minus, Na plus and Cl minus. Here, this Na plus minus Na plus Na plus get cancelled. This is plus Na plus, this is minus Na plus. Plus Cl minus minus Cl minus get cancelled. And finally, you get limiting molar conductivity of CH3CO minus and H plus. Okay. Next question. Limiting molar conductivity of this part we have to find. This is a question. See, NaCl is given, HCl is given. NaAC means sodium acetate, CH3COO minus. We have to find limiting molar conductivity of HAC. HAC means acetic acid. Okay. Can you do this? Can you do this? Note down these values. For NaCl, all of you note down these values. For NaCl, what is the value? 126. For Cl minus HCl, what is the value? 425.9. For sodium acetate, CH3CO minus, CH3CO Na, 91. Note down these three values. How to find the limiting molar conductivity of acetic acid? What is the formula? Go back. To get the limiting molar conductivity of acetic acid, you have to add sodium acetate and HCl. You have to subtract NaCl. Get this point? Note down this point. Now I am coming back to the question. You do one thing. You add the value of HCl and sodium acetate. These two values you add. That means 91 and 425. You add these two values and subtract the value of NaCl. 425 plus 91 is approximately 515 or 516. 516 minus 125. 516 and minus 125. Approximately what we get? 425.9 plus 91 minus 126.5. 390.5. 390.5. That is the first option, right? First option. Next, second application, relationship between alpha lambda m means molar conductivity at the given concentration, molar conductivity at infinite dilution. Okay. Dear students, you please join if the class is over. Again, once again you join, because just 5 more minutes we need, that's all, so that this topic will be completed. And today we are taking a lengthy class. Okay. Uh, Please rejoin once again after the, if the class is ended. This is the second one. Note down here what is alpha. Note down this formula. Alpha is a degree of dissociation. Alpha is called degree of dissociation. Lambda m is called molar conductance at any concentration. Lambda m is molar conductance at any concentration. Lambda m naught is molar conductance at infinite dilution, or it is called limiting molar conductance. Okay, note down this. Otherwise, at least take a screenshot of this. Now we will get a problem, one small problem. You have to solve that problem. Alpha is equal to lambda m by lambda m naught. Remember this formula. Degree of dissociation is equal to molar conductivity at any concentration by at limiting molar conductance. This is the question. Calculate the degree of dissociation alpha and at 298 Kelvin. These are the values given. All the values given now. This is the molar conductance at any concentration. Molar conductance at any concentration. This is the molar conductance at a given concentration. Actually, see here, molar conductance of at any concentration is lambda m value is given. Molar conductance at infinite dilution, acetate ion, H plus ion separately given. Please note down this point. You add these two, because this is acetic acid now. I will tell you. I'm going to take the screen here. Small point. The formula is alpha is equal to molar conductance at any concentration by molar conductance at infinite dilution at zero concentration. Here the given values are molar conductance at any concentration of acetic acid is given. No problem with this value. Molar conductance at infinite dilution of acetate ion is given separately. Molar conductance at infinite dilution of H plus ion is given separately. But we want molar conductance at infinite dilution of acetic acid now. Acetic acid we want. So you add these two, both you add. Then molar conductance at given concentration of acetic acid by molar conductance at infinite dilution of acetic acid. You add these two, and this value is given. After adding these two, you will get one more value and divide both the values, and you will get the answer. Very simple. So these are the options given. So we'll see which option we'll get directly. Molar alpha is equal to molar conductance at the given concentration 11.75 by acetate ion concentration by plus H plus ion, molar conductance at infinite dilution of H plus ion. Then you will get 0.03. So option. Next, here you see a relationship between Ka, alpha and C. K is a dissociation constant. Note down, I will give this. K is a dissociation constant. Alpha is, C is concentration. Alpha is a degree of dissociation. This is the formula. Ka is equal to C alpha square by 1 minus alpha. Okay. Degree of dissociation constant is equal to C into degree of dissociation square minus 1 minus alpha. How to find alpha? Just we got a formula, no? One problem we have done now. Remember that. Now one small question. So solutions are saturated. One second. That's all. No problem is given on that. I have not given any problem based on the previous formula. You just remember that formula. when we discuss about some what to say some objective questions, then we will try to recall. Please note down all these points. Here you see solutions are saturated at infinite dilution. Infinite dilution means when you add more and more and more water, then uh, molar concentration at molar conductance at any given concentration becomes is equal to molar conductance at infinite dilution. Then molarity is equal to solubility. Write down this relation. Molarity is equal to solubility. Molarity means concentration. Concentration is equal to solubility. We are going to get one important formula of solubility. Okay. Thus, this is the formula. See, molar conductance at infinite dilution or limiting molar conductance. Limiting molar conductance is equal to K into 1000 by solubility. Do you remember in the last class this formula to you? But in the place of solubility, molarity I have given. Molarity. Got the point? Okay. Here in the place of molarity, we have taken solubility because molarity is equal to solubility. Remember this? Or solubility is equal to K into 1000 by limiting molar conductance. So remember the second form or first form. You can interchange both of these. One small question is given. The specific conductance at 25 degrees Celsius of a saturated solution of AgCl is specific conductance is given. Specific conductance means, okay, specific conductance means, be careful. Specific conductance means conductivity. Conductivity means kappa. That is the kappa in that formula. That value, kappa value is given 1.826 into 10 raised to minus 6. Mo means ohm inverse. Ohm inverse, centimeter inverse. If the limiting molar conductivity of AgCl, limiting molar conductivity also is given, means lambda naught also given. That is 138.26 mho centimeter square per mole. Find out the solubility of AgCl. What is the formula for solubility? Formula for solubility is kappa into 1000 by limiting molar conductivity. Kappa value given, limiting molar conductivity is also given. So you have to substitute, that's all. Okay. So solubility is equal to kappa into 1000 by limiting molar conductivity. So values just we have substituted, and finally we get 1.89 into 10 raised to minus 3. Try yourself and whether you are getting the same or not. Okay. Next, last one, relation between one small question. Relation between alpha, lambda, lambda m, lambda naught m is. What is the formula for alpha? Please respond. If you have written notes, you can easily answer this. Alpha is equal to lambda m naught by m, lambda m or lambda m by lambda m naught. Which option?
C, sir.
C.
C.
Good. Excellent. C, option C. Okay. So by this class is over. Very lengthy class. I will make this class into 2 different videos because it becomes very lengthy, nearly 1.5 hour to more than 1.5 hour. So I will make this 2 parts. Before Kohlrausch Law, 1 video. After Kohlrausch Law, another video. Then it will be separately. Okay. Our next topic will be electrolytic cells, electrolysis, Faraday's laws. This Faraday's laws also very important, both for your intermediate or IPE exams, board exams, as well as competitive exams. Very important, that we'll discuss in tomorrow's class. Tomorrow's timing, you can tell me in the WhatsApp group. Otherwise, I am planning to take morning 10 o'clock. If it is okay, then you give your opinion. Otherwise, tell me any other timings that you are comfortable with. Only three are joined: Ramaya, Umaiza, and Wahid. Right? We'll see tomorrow in tomorrow's class. And tomorrow's class also may be little lengthy because tomorrow is holiday for me and for you also. And Monday also holiday for me. And Monday we will go as usual because you may have colleges. Okay. Okay. Good night, dear students. We'll meet in the next class, tomorrow's class. Bye. Take care.
Thank you.